Across the infinite expanse of space, I begin my narrative by guiding you through a cosmic prologue that unfolds the genesis of our galaxy, a subject that has long intrigued scholars and astrophysicists alike. My narrative delves deeply into the interplay between the primordial forces that shape the cosmos and the untamed potential that resided in every particle. In the vast darkness where gravitational forces sculpted nebulous clouds, early star formation ignited like sparks in an ancient forge, hinting at incredible energies and the chemical diversity required for life. Advanced analysis of cosmic microwave background radiation further illustrates the vestiges of the Big Bang, offering quantitative insights that challenge even the most established models of cosmic evolution. This narrative brings together intricate numerical simulations and detailed observations, exploring the interplay between dark matter and baryonic matter in seeding the formation of the first galaxies. My account investigates complex dynamics, where matter congealed under intense pressure and immense gravitational pulls to ultimately ignite nuclear fusion in the hearts of young stars. Through carefully calibrated spectroscopic studies and statistical models, I reveal the layered chronology of elemental synthesis that set the stage for later, more complex cosmic architectures. Embracing a relaxed yet precise tone, I invite you to consider the galaxy not as a monolithic body, but as a dynamic tapestry woven from the threads of energy, time, and matter. Like an ancient manuscript inscribed with mathematical precision, our galaxy's story is etched in every celestial coordinate and spectral line. As we explore these early moments, imagine the turbulent beauty of a universe in its infancy, where each emerging star was a testament to the relentless power of nature, and every spiral arm held the promise of future wonders. Thus, the prologue lays a quantitative and qualitative foundation for our cosmic journey. Delving further into the deep history of our galaxy, I examine the ancient origins that underpin its present magnificence. In the earliest epochs, colossal nebulae composed of hydrogen, helium, and trace elements coalesced under gravity's pull, forming the first generation of stars. Detailed astrophysical models, such as those using N-body simulations and hydrodynamic turbulence equations, highlight the chaotic yet mathematically predictable nature of these formative processes. Statistical analyses of star cluster distributions reveal that the initial mass function played a crucial role in determining stellar lifetimes and supernova events, which in turn enriched the interstellar medium with heavier elements. Researchers have found that even minor variations in elemental abundances could alter the evolution of star formation, leading to a cascade of chemical reactions that shaped molecular clouds. Astrophysical observations from space-based telescopes have provided precise measurements of cosmic background fluctuations, lending insight into the subtle density variations that governed early structure formation. The integration of data from various instruments, including radio interferometry and high-resolution spectrography, has allowed for robust, fact-driven reconstructions of the galaxy's evolutionary timeline. In particular, a combination of computational astrophysics and refined algorithmic analysis has uncovered intricate details concerning the fragmentation of primordial gas clouds. These cores later ignited under the pressure of gravity, setting off a chain reaction of nuclear fusion that lit up the universe. Advanced mathematical models illustrate how perturbations in dark matter distributions contributed not only to gravitational wells, but also prompted symmetry-breaking processes vital for the emergence of complex structures. Evidence indicates that the interplay between dark energy and dark matter produced subtle but measurable effects that are still observable in the galaxy's spiral structure. Thus, the ancient origins of our galaxy demonstrate a fusion of theoretical calculations and empirical evidence, merging elegant physics with deep time narratives. In this historic segment, every particle, photon, and magnetic field line contributes to an elaborate cosmic equation that continues to be deciphered by researchers dedicated to understanding the universe's earliest chapters. Every measured parameter, from the symmetry of spiral arms to the variability of stellar lifespans, contributes to a grand cosmic puzzle that continues to engage some of the most brilliant minds in astrophysics today. Thus, in studying these early epochs, we trace. Transitioning from the silent genesis of celestial formation, my narrative now shifts to the rise of galactic empires, and the turbulent conflicts that have defined epochs of cosmic order. In the vast expanses between star clusters, ancient civilizations harnessed energy from pulsars and black hole accretion disks to power their colossal fleets, their strategies as mathematically rigorous as the orbital mechanics governing their interstellar travel. Advanced civilizations emerged with an engineering mastery that allowed them to manipulate gravitational fields for rapid transit across the cosmos, creating intricate networks of wormholes and hyperspace corridors. Historical records etched in ionized gas signatures and magnetized plasma echoes reveal that these empires expanded not merely through conquest, but through a blend of scientific diplomacy and algorithmic governance. In a time marked by technological ascendancy, data archived from relic satellites and deep space probes illustrate detailed accounts of interstellar conflicts where energy shields and particle beam weaponry clashed with the forces of dark matter augmented propulsion units. Calculated maneuvers were executed with precision, often employing statistical optimization and game theory to determine the battlefield advantages. The constant interplay between offensive innovations and defensive countermeasures created a dynamic equilibrium, reflecting the natural laws of entropy balance observed in physical systems. Quantitative analyses of conflict data have shown cyclical patterns approximating logistic growth curves, underscoring how resource scarcity and technological leaps drove each empire to new thresholds of ambition. Yet, these cosmic conflicts were not solely destructive. Many empires interwove scientific collaboration with military strategy, establishing joint research outposts near neutron star clusters and shared energy grids powered by quasar emissions. Diplomatic communiques, encoded in neutrino beams and gravitational wave modulations, were as significant as any physical battle. These intricate communications protocols relied on advanced encryption and error-correcting codes, comparable in complexity to those governing quantum computing systems. In many historical episodes, alliances were formed on the basis of extensive data exchange, fostering innovations that allowed them to integrate disparate technological systems into a coherent, galaxy-spanning infrastructure. As conflict evolved over millennia, the balance of power shifted with the advent of artificially intelligent strategic systems and automated fleets capable of executing decisions at sublight speed. Historical records indicate numerical escalations in fleet sizes reaching into the millions, with individual deployments meticulously coordinated by algorithms that simulated potential outcomes millions of times per second. In examining these events, it becomes clear that the rise and fall of galactic empires were governed by principles not unlike those of a complex adaptive system, where local interactions led to emergent large-scale order. Each empire's narrative is etched into cosmic history with data-rich chronicles, underscoring a legacy of relentless ambition, scientific ingenuity, and the ever-present risks inherent in the pursuit of interstellar dominance. Over centuries, meticulous records of strategic encounters have enabled modern historians to apply advanced statistical methodologies to decode the interplay of variables influencing these epic confrontations. Extensive databases compiled from recovered telemetry and reconstructed archival transmissions provide quantitative evidence of battle casualty rates, resource allocations, and technological advancements. The synthesis of these records with contemporary models of chaos theory and nonlinear dynamics has revealed surprising parallels between cosmic conflict and natural phenomena such as solar flares and asteroid showers. Detailed numerical simulations indicate that minor tactical adjustments could reverberate exponentially across multiple cycles of engagement, shifting the strategic equilibrium within entire star clusters. This harmonious blend of observational data and theoretical analysis forms a potent narrative of progress and peril, illustrating how each calculated move on the vast galactic chessboard has left measurable imprints on cosmic history. In my narrative, these recorded events underscore the enduring balance between ambition and survival. Entering a phase of profound transformation, I now recount how cultural evolution and technological revolutions reshape the galaxy in unexpected ways. In a critical period when archaic traditions met breakthrough innovations, civilizations redefined their identities by embracing scientific progress without forsaking their rich cultural heritages. Detailed analyses of historical records reveal that diffusion of knowledge, enabled by vast data networks and interstellar communication arrays, catalyzed shifts in societal paradigms. Technological revolutions, from subspace communication to quantum entanglement networks, not only optimized trade and governance, but also encouraged harmonious exchanges between long isolated worlds. Rigorous studies based on complex system theory demonstrate that cultural evolution in the galaxy did not proceed linearly, but rather through punctuated equilibria, where rapid bursts of technological adoption followed extended periods of relative stability. Researchers have employed sophisticated algorithms to model these transitions, using network theory and dynamic systems analysis to capture the interplay of cultural motifs and technological infrastructures. Statistical distributions of artifact origins and digital relics confirm that nearly every civilization contributed uniquely to an unparalleled repository of shared knowledge. Detailed metrics, including innovation indices and adoption rates of new technologies, further substantiate the claim that transformative inventions acted as catalysts for both economic and social metamorphosis. At the heart of this transformative moment were collaborative endeavors fostered by scientific collectives and intellectual symposia held in spaceborne institutes. Advanced simulation tools uncovered that even minor innovations, such as improvements in gravitational wave communication, had cascading effects on the societal structure, leading to more decentralized and resilient interstellar communities. These breakthroughs accelerated exploration, paved the way for sustainable energy solutions derived from stellar radiation, and redefined human conceptions of progress. Through the meticulous examination of archival data, several pivotal technological inflection points have been identified as the turning moments that realign the trajectory of cultural and technological development across galaxies. The fusion of ancient wisdom with modern science during this era continues to inspire current research and serves as a beacon for future advancements. During this era of relentless transformation, empirical studies have started to unveil the quantitative impact of these revolutions. Researchers have measured the exponential growth in information transfer rates and the corresponding decline in communication lag, noting improvements by factors of up to 10 to 3 over previous generations. Complex simulations corroborate that the acceleration in technological adoption is directly correlated with an increased rate of cultural exchange, a finding supported by regression analyses with a high coefficient of determination. Detailed examinations of social networks across systems reveal that enhanced connectivity contributed significantly to innovation diffusion. Additionally, newly developed computational frameworks have allowed scientists to simulate potential future scenarios, ranging from the emergence of unified galactic protocols to the possibility of autonomous cultural evolution. This synthesis of empirical evidence and simulation techniques reaffirms the transformative power of convergence in shaping a cosmic community. Approaching a pivotal climax in this cosmic saga, I now describe the great convergence that united a once fragmented galaxy into a cohesive civilization. Over millennia, the divergent paths of isolated star systems and rival factions began to intersect through gradual information exchange and shared scientific breakthroughs. Detailed archival data and high-resolution cosmic surveys reveal that subtle gravitational perturbations and coordinated energy pulses played a decisive role in drawing distant worlds into a common orbit. Advanced models of network dynamics suggest that this unification was not a sudden occurrence, but emerged from cumulative interactions, much like the synchronization observed in complex natural systems. Collective endeavors in interstellar research and diplomacy fostered cross-cultural alliances that transcended political and spatial boundaries. Empirical studies based on vast data sets collected from coordinated space missions indicate that this convergence was closely linked to a significant reduction in systemic entropy, a change quantified by shifts in information theory metrics. Sophisticated analyses employing techniques from fractal geometry and chaos theory show that hierarchical patterns began to form amid the seeming randomness of previous conflicts. The resulting alignment of cosmic resources and intelligences created feedback loops that bolstered both scientific innovation and social cohesion. Archival records, enriched by precise spectral analysis, document diplomatic summits, high-level negotiations, and the formation of a unified governing council that established new laws based on equitable resource sharing and collective advancement. In my narrative, the cosmic convergence stands as a moment of profound transformation, a unification achieved through both deliberate effort and the natural drive toward order. This fusion of disparate elements into a singular, harmonious structure not only redefined the political and cultural landscape of the galaxy, but also laid the groundwork for future explorations and innovations. Every historical metric, every measured gravitational anomaly, and every recorded diplomatic envoy contributes to an enduring legacy that continues to illuminate our path forward. In reviewing the convergence, I integrate extensive numerical data and gravitational simulations that model the collective impact of converging civilizations. These models indicate an increase of over 30% in systemic organizational efficiency and a dramatic reduction in interstellar conflict rates. Such quantitative insights, derived from decades of meticulous observation, confirm that cosmic unification resulted in a more resilient and adaptive galaxy, prepared to meet future challenges with unified strength and visionary cooperation. This synthesis of empirical evidence and simulation techniques reaffirms the transformative power of convergence in shaping a cosmic community. Concluding this expansive narrative, I reflect on the intricate tapestry woven through epochs of cosmic evolution. My account, rich with numerical data, advanced simulations, and meticulously gathered empirical evidence, illuminates the galaxy's journey from chaotic beginnings to a sophisticated network of interconnected civilizations. Detailed analyses confirm that every measurable phenomenon, from gravitational anomalies to cultural inflection points, has contributed to the current order of the cosmos. This narrative invites experts to consider not only the grand scale of historical events, but also the nuanced interplay of fundamental forces and emergent phenomena that continue to shape our universe. Advanced models of astrophysical dynamics and cultural progression underscore a future ripe with potential discoveries. In this ever-evolving cosmos, new innovations and data-driven insights promise to reveal further layers of complexity. As research deepens, the legacy captured within these chronicles serves as both a reference and an inspiration, guiding future explorations and fostering a holistic understanding of the galaxy's true nature. With every analytical breakthrough, we get closer to unraveling the enigma of our celestial heritage and envisioning the next chapter in a saga written across the stars. As I step back to view this grand cosmic narrative, I am reminded that each discovery and insight serves as a stepping stone to deeper understanding. The synthesis of rigorous science and imaginative exploration continues to propel us forward into uncharted territories, promising a future where the mysteries of the galaxy are gradually unveiled, one breakthrough at a time. Each advancement deepens our cosmic perspective,